So what we're going to be looking at is we're going to be discussing a very important process in the body known as homeostasis, right? Homeostasis. So you may have seen this word before. You may have come across this word in a textbook. But essentially, what we're talking about when we're describing homeostasis is we're describing an internal steady state of conditions, right? So we're describing an internal steady state of conditions, right? Internal steady state of conditions. So what this means is that we are trying to keep some variable. We're trying to keep something, some maybe range for some given value. We're trying to keep it within certain ranges, some given parameter within certain ranges, right? So examples of things that we can try to keep in homeostasis or keep in a homeostatic range are things like heart rate, right? So we try to keep our heart rate in a normal range, right? Not necessarily one specific number, but in a given range, right? So a normal heart rate may be somewhere between 60 and 100, right? And so we're trying to keep it somewhere within that range most of the time, right? Most of the time. Other things that we may think about could be things like blood pressure, right? Excuse me. We're trying to keep our blood pressure somewhere around 120 over 80 millimeters of mercury, right? Somewhere in that given area, right? Something else that we may try to keep in homeostasis is our temperature, right? Our internal body temperature, right? 98.6, somewhere around that. Again, there's a given range. Other things that we may think about are things like blood sugar, right? The amount of the the amount of sugar, the amount of glucose that we have in our blood, right? We want that to stay in some given range, right? So the control of all of these, okay, heart rate, blood pressure, temperature, blood sugar, all of these are controlled by what is called negative feedback. Negative feedback, right? Now, negative feedback, this does not mean bad. This does not mean not ideal. Negative feedback is simply a process in which we take an abnormal value for some parameter. So say that parameter is heart rate, right? And we have a heart rate that is too high. Okay, a heart rate that is too high. Because this is controlled by a negative feedback mechanism, we end up trying to lower our heart rate, right? So we say a normal heart rate is 60 to 100 beats per minute, right? And so an abnormal heart rate would be 117 beats per minute, right? If that is like a resting heart rate, that is a really high resting heart rate. And so negative feedback is trying to bring it back down toward that 60 value, right? Or back to a normal value, right? It may not necessarily be 60. So say it's trying to bring it back to, say, 75, right? We're trying to move it and keep it within some given parameter. Same thing for blood pressure, same thing for body temperature, same thing for blood sugar, right? This is something called negative feedback, right? So don't think negative means bad, but think negative means as we move out of a normal range, we try to reverse that and bring us back to normal, right? So again, a good way to think about this is if you were to have any of these values, so value for heart rate, blood pressure, temperature, blood sugar, if you were to have the value for those parameters be abnormal, would you want it to continue being abnormal, or would you want to return it back to some normal range, right? And so for all of these, we'd want it to return to a normal range, right? Now, there's a second type of control that's not negative feedback, but you may have guessed it. This is called positive feedback, right? Positive feedback. And so positive feedback is largely the exact opposite of negative feedback, right? So negative feedback, we know that if we become, or if we're moving in one direction, so we're moving toward a higher and higher heart rate, we're trying to reverse it, right? We're trying to bring it back down. Positive feedback is exactly the opposite in the sense that as we move in one direction, our body is going to initiate processes that continue to move us in that same direction, right? So there's two really good examples of positive feedback in the body. There are several, but these are two really good ones. One of these is, let me pick a different color here. Pick a different color that stands out a little bit more. One of these is labor. One of these is labor, so the childbirthing process. And another really good example is blood clotting, right? Blood clotting. So you cut your finger, you begin bleeding. The process of forming that clot, the sequence of events is under the control of a positive feedback mechanism, right? So again, positive in this case doesn't necessarily mean good. It just means that we're continuing to move in a particular direction, right? Now, for essentially all homeostatic feedback systems, right? Homeostatic feedback systems. There's a sequence of events, right? There's a sequence of events, and so there's three kind of main things that you have to have for a homeostatic feedback system, right? So the first thing that you have is you have to have a stimulus, right? You have to have a stimulus. In this context that we're talking about, primarily think here negative feedback, right? So you have to have a stimulus. You have to have something that causes a given value to move outside of a normal range, right? So heart rate, you have to have something that causes the heart rate to move below 60 or above 100, right? Temperature, you have to have something that causes it to move well beyond 98.6, something like that, right? So you have to have a stimulus, right? Along with the stimulus, you have to have something to detect the stimulus. So you have to have a receptor, right? You have to have a receptor to pick up or detect or receive that given stimulus. You may see these called a sensor as well, right? So if you see the term sensor, that's essentially referring to a receptor, right? The receptor is then going to initiate a signal or send a signal to something called a control center. Control center. And this is essentially, you may also see this called an integrating center. And so this is essentially what is receiving the input. So you have some stimulus that was picked up by a receptor. That receptor is going to notify a control center, and that control center may be in the brain, it may be a particular organ or other structure, but it's something that's going to receive that signal. And then the control center is going to initiate a signal itself. It's going to give an output to some target. Okay, so some target, we'll say effector. Okay, so meaning the tissue, the organ, the gland that's going to bring about the change. Okay, and then lastly, you will have the response, right? You will have the response of whatever that effector happens to be. Okay, whatever that effector happens to be. So